Hello everyone, yay math. All right, some basics here. The goal eventually is to be able to find the area of a sector. A sector is just, this thing right here. It's a slice of pizza, really. How much area is in that slice of pizza? So, before we get there, let's just start off with some basics here. Area of a circle. Well, the area of a circle is pi r squared. Right now, the whole thing's 10, which means from here to here would be 5. So we're going to do area equals pi 5 squared. And order of operations says we do exponents first. So I'm going to do 5 squared. It's going to give me 25 times pi. And if I use my calculator, 25 times pi, I'm going to get 78.54. Square inches. Now, it should be noted that you can also just leave this in terms of pi right here if you wish. That's fine, and this is also fine. The advantage of this is there's no rounding ever. And I don't have to use a calculator really, I can just stop right there. The next one, same thing. Area is pi r squared. So 3 squared is going to give me 9 pi, and that's a correct answer right there. 9 pi square meters, or I can actually multiply it out, and 9 times pi is 28.27 square meters. That works too. The next one, we have to go backwards. So I'm going to start with this one actually. Area equals pi r squared. They give me the area though, so I'm going to put 12 equals pi r squared. So how do I get rid of this pi right here? I don't do square roots first. I have to get rid of this pi first. So I'm going to divide both sides by pi. So then we get r squared is, let's see here, calculator, 12 divided by pi is 3.81. There's some other numbers there. Now I'm actually going to take the square root of both sides. And the square root of that answer is 1.954 and some other stuff. So there we go. This one right here, same sort of thing. Area is pi r squared. The area though on this one, they gave it to us in terms of pi. So I'm going to put 10 pi right there equals pi r squared. Same thing, going to divide by pi so that those cancel out. Oh wait, those also cancel out. If I take 10 times pi and then divide it by pi, I'm just left with 10. Then I got to take the square root of both sides, so r is equal to the square root of 10. Or if you actually want to work it out, it's 3.16 and something else. Either one works. This is fine, and this is fine as well. Now, that's all just stuff that we've kind of done before. Okay, going backwards to figure out the missing thing, that's just algebra. This is also something pretty simple. How many degrees are in a circle? And I'm sure all of you said 360. So how many degrees would this be? Well, I have half of the circle, so I'm going to take half of 360. And if you got 180, that would be correct. That's 180 degrees from there to there. On this one, there's 1, 2, 3 parts of the circle. So it's 1 out of 3 of them are shaded. 1/3 of 360 gets me 120 degrees. This one's a little bit tougher. How much is each one of these little parts right there? Well, there's 2 different ways we can do this. First way is I can say, okay, 360 divided by 8, because I see 8 parts right there. 360 divided by 8, plug in my calculator, and I get 45 degrees. But obviously that's not 45 degrees. There's 3 of them though. 1, 2, 3. So 3 times 45 is 135 degrees. Another way to look at those, say, look, Mr. Kuhn, you're making it too hard. There's 1, 2, 3 out of 4, 5, 6, 7, 8, 3/8 of 360. And if you multiply those, Mr. Kuhn, you're going to get 135 degrees. Both those are correct. Down here, what fraction of the circle is shaded? Well, I know some people go like, oh, it's 360 divided by 60. That means 6, so that's 1/6. And you're correct. It's a little harder with this one, though. Well, some people might look at it and just say, well, Mr. Kuhn, I can just look at that and say, well, that is 1, 2, 3 out of 4 parts. So it's obviously 3/4, Mr. Kuhn. And you would be correct as well. But then this one gets a little bit harder because it's not a nice even number. So how can we figure out the fraction of this? Well, one way is we know we can split this up, a circle up, into 360 degrees, right? So there's 360 of these little degrees in here. And how many do we have? 140 of them. So actually, this is 140 out of 360. And yes, this can be reduced to 7 out of 18. But I'm going to say something here. There's no law that says we have to reduce. You can leave your answer like this. In fact, that's actually even easier for this one. What fraction of the circle is shaded? 270 out of 360. That's the same thing as 3/4. There's no law that says you have to reduce all fractions. Sometimes it's better not to reduce them. So like this one would be 60 out of 360. And yes, that does reduce to 1/6, but sometimes it's easier just to do it like that. All right, the next one right here. Find the area of the shaded part. Well, let's see here. It's a circle. I know I got to find the area of it. So I'm going to find the area of the circle. So I'm going to do area is pi r squared. And that's going to give me, well, 6 squared is 36 times pi, which is 113 point something. I think it's like 07 or 06 or something like that. Now, I don't want the whole circle, though. I only want 1/4 of it. So now what I'm going to do is 1/4 of 36 pi, or 1/4 of 113. And if I do that, well, let's see here. 36 divided by 4 is 9. So I should get 9 pi, which is 28.27. On this one, I'm going to do the same sort of thing. I'm going to find the area of the whole circle. Pi r squared. 10 squared gives me 100. So I can do 100 pi, or that is 314. But I don't want the whole thing. I only want 1/3. 1/3. 1/3 of 100 pi. Or 1/3 of 314.159. And the answer to that, well, I can be lazy or just do it in terms of pi. 100 pi over 3, or actually use my calculator. 100 times pi divided by 3. 104.719. There's more numbers after that. Now you may see a pattern here. I'm taking the fraction of the circle times the area. The fraction of the circle times the area. And that's actually the formula up here. I'm going to take the fraction of the circle that we want, and we'll multiply it by the area of the circle. Now, some people are like, well, that's not a very good fraction. That's not a very good equation, Mr. Kuhn. Well, I think it's better than this one. Some people are like, oh, so it's always degrees over 360 pi r squared. Yes, you're correct. But the big thing is, this tells me where everything comes from. The fraction of the circle is just the degrees over 360. Back here we saw degrees over 360 is 1/6. It's the fraction of the circle. Same thing. Degrees, 270 out of 360. That reduces to 3/4. So this is how we can find the fraction. But if it's not in degrees, we can still just use this one though. And then the area of the circle, yes, that's pi r squared. So both of these are correct. But the advantage of this one is it tells you where everything comes from. It makes a lot more intuitive sense as well. So this sector area, I'm going to put an S in front of this. Sector area is the fraction of the circle times the area of the circle. So now I'm going to come down here and do this last one right here. Now I'm like, okay, so the sector area is the fraction of the circle. The fraction of the circle is, well, it's not a nice, neat one like this, but I know I have 100 out of 360 degrees. I've got 100 degrees out of 360, so that's my fraction. The area of the circle, 3.7 squared. So I'm going to do 100 divided by 360. So that's 0.27 repeating. I'm going to take that times pi r squared. Pi times 3.7 times 3.7. And I should get, there we go. .946, and there's more digits after that. Square inches. So the big thing to remember from this is, if you're trying to find the sector area, you take whatever fraction of the circle you do times the area of the circle. Thanks for watching.